arithmetic or
Arithmetic.
Arithmetic. The accent is on a different syllable. It's arithmetic. Arithmetic, add, subtract, multiply, divide, etc. When we're talking about a sequence and a pattern, it's arithmetic. So it's like read and read, right? Depends on R-E-A-D. I read a book versus I am going to read a book. Yeah? So it's kind of just a stop. All right, so first, what's a sequence? Fantastic. It's a list of numbers that follow a pattern, or a set of numbers that follow a pattern. It doesn't necessarily have to be numbers, but in math class, we talk about numbers. Okay, so give me a sequence, a good one, not a boring one. I don't want to do that. Give me a sequence. Okay, yeah, okay. So Corey's sitting in front, so this is what I heard first. And what do we call that? What kind of sequence? Fibonacci sequence, yeah. Give me the other one.
1, 8, 27.
1, 8, 27. What's next, Brian?
256.
No. 64?
Is it? Oh, wait, no, I was
64, Brian. And then 120.
Well, a lot of you are like, well, it's 64, not 256. How did you know what it was?
No, it takes me like a good 10 minutes.
I said for the wrong power.
It is 64.
It's
125.
1 cubed, 2 cubed, 3 cubed, 4 cubed, yes? Right? So neither one of these is arithmetic or geometric.
What does geometric mean?
Yeah, that's a good question. What does geometric mean?
It's like multiple.
2, 4, 8.
It's like 2, 4, 8, that's good. That is, that's geometric. What's geometric? What's arithmetic? We'll get there. Take a stab, please, at an arithmetic sequence.
1, 2, 3, 4.
1, 2, 3, 4, 5 is boring. 1, 2, 3, 4, 5 is boring. Give me something creative.
1, 3, 5, 7.
All right, 1, 3, 5, 7, 9, blah, blah.
It's quite interesting.
Creative and interesting, I suppose, is subjective. All right, Michelle, this is what you gave me, and it is arithmetic. Explain what that means.
Arithmetic is the pattern is basically adding or subtracting.
There you go. Arithmetic. The pattern is basically adding or subtracting. Okay. Arithmetic is a created, we'll just say created. A sequence created using addition or subtraction. Arithmetic are nice because we can create a formula. So in the homework, excuse me, maybe not a pattern like this one, but you were asked to find the 100th term. And you could be doing adding forever in your calculator and trying to figure out which one's the 100th term. But of course, there's a pattern. So I'm going to take, I don't want to use 1, 3, 5, 7, 9, which is a fantastic pattern, but let's use, how about 6, 11, 16. Hopefully I've done that. This is a new sequence, and we're going to develop a formula because you know I don't like it when you memorize. So if we can derive it, hopefully that'll be a lot easier. What are you adding each time? 5. What are you adding each time? You're adding 5. Therefore, it is arithmetic. You have a question?
Oh, I was just going to say,
So you're adding 5. You're adding 5 each time. Therefore, this falls under the arithmetic category. Do you agree that you're adding 5? What are you adding 5 to?
Previous.
Previous term. Agreed? So the next term would be 26, keep going, 31, 36, etc. But what if I asked you to find the 100th term? You do not want to, on your calculator, go 21 plus 5, plus 5, plus 5, plus 5. You'll be here forever, correct? Okay, this is the last place you want to be forever. So here we go. I'm going to write this vertically. And you'll see why I did that in a minute. Just want to organize our thoughts a different way. Six to 11 is plus 5? Yes. And 11 to 16 is plus 5. And I know some of you, just like you can figure it out, that's great, but you have to understand how to derive the formula. 16 to 21, plus 5, and so on and so forth. Yes? Okay, so that 5 is called the common difference. In this particular problem, you are adding 5 each time, and 5 is known as the common difference. Well, why difference? Difference means subtraction. Well, the difference between 11 and 6 is 5. The difference between 16 and 11 is 5. And the common difference has a letter. What do you think?
N.
No, not N. N is for term numbers.
T.
No.
D.
D. Some of you may have said D. I didn't hear you. D for difference. Yeah? Not too bad? Great, fantastic. We need to come up with this formula. Where did I start adding from? Like, where was the beginning? 6? Agree with that? I started from 6, and then I went to 11, but then I started at 11 and went to 16, but then I started at 16 and went to 21. Yes? Okay, but I don't like that. So to go from 6 to 11, I added 5. To go from 6 to 16, I added 10. Yeah? And to go, I'm going to run out of room here. To go from 6 to 21, I added. Huh? So to go from 6 to the next term, what am I going to add? 20. And to go from 6 to the term after that, I'm going to add. Great, fantastic. 5 is the common difference, yes? How many 5s are in 10? Trick question. 2. How many 5s are in 15? 3. So what I added was my common difference twice. What I added was my common difference 3 times. There you go. Victoria, what is it?
N.
And
It's like the equation, it has like n minus.
it has something to do with n minus 1.
Yeah.
Where does the n minus 1 come in?
It starts.
So the first term was 6. First term was 6. Yeah? The second term was 11, which is 6 plus 5. And the third term was 16, which was 6 plus 5 twice. And the fourth term, I wrote 6, no, that's right. The fourth term is 21, which was 6 plus 5 3 times. Without, possible, I want you to just figure it out. Give me a pattern, I should say. The 20th term is going to be 6 plus 5, how many times? 19. Yes. 19 terms. How many 5s did I add the first time? None. I add 5 0 times. I add 5 once. I add 5 twice. I add 5 3 times. What is the relationship between the term number and the number of times I add 5? And minus 1. There you go. So find for me the 57th term without your calculator. Use your brain. No calculator. Do it the long way. Where do I start? Multiply.
56 times 5.
Plus how much?
6.
250 plus 286.
Yes.
Yeah? Yes? We good? 286? Did I make a mistake? All right, now give me a formula for this particular. Give me a formula. If I have a formula, I can just plug right away. You have an answer, Amy?
Yeah.
1 second. Then you can give it to me. Go for it, Amy.
Oh, I have a question and an answer. Are there multiple formulas for a set or a
Yeah.
sequence?
There are, it's like saying 5, I don't want to use 5. 10 plus 6n minus 1. Just making this up. This is the same thing as 6n plus 4, yeah?
Mhm.
Are they the same?
Oh yeah.
One's simplified, one's
Okay,
not.
okay, I see.
Go for it.
I have the simplified one.
I like that.
Yeah, 5n plus 1.
Uh,
Yeah, that works.
you're missing something big.
T sub n.
Thank you. What? 5n plus 1? So I would imagine, this is simplified. What was before that?
6 t sub n is equal to 6 plus n minus 1 or 5n minus 1.
Yes? Okay, so here comes the generic formula. I just lost my train of thought. We started with 6, and then 6, blah, blah, 6, blah, blah, 6, blah, blah. What do you call 6? What's the generic term for 6 in this particular sequence? What is it? Constant. Where is it represented in the list? First term. 6 was the first term? Oh, this does not look good, but oh well. Nth term. We just derived the whole thing. We started with 6, but in general, it's not always 6. What do you call 6?
Constant.
The constant, we're in the list. The first term. You're always starting with the first term. In this case, the first term is 6. Maybe the first term is going to be 0.39. Maybe the first term is going to be pi. Plus, you added 5 a certain number of times, correct? What's 5 called? The common difference, which is represented by D. And how many times did we add that? Term number, which is n, minus 1. Arithmetic only. Only if it's addition and subtraction. Only if it's addition and subtraction. there are lots of things, like Fibonacci has a pattern. It's not arithmetic. All right, I want an equation, and I want you to find, without your calculator, the 25th term. And this is the pattern. Sorry. No calculator, you can figure out 24 times blah blah. Bless you. Oh shoot. Share with your neighbor. When you're ready, help each other.
Yeah, I just. Just like my You can see what they tell me.
Then I probably did something. Yeah, it's 20 minutes.
Is it arithmetic, first of all? It is. I could have tricked you, but I did it. What's D? -4. The common, like subtraction is part of the arithmetic category. So you are subtracting 4. Is that what you just told me? Is that what you told me? Okay. Subtraction. Okay. Add the opposite. All right. What's the first term? 3. You don't have to show any of this. I'm walking through it so you can put it all together. So the nth term. What's the first term?
3.
What's D? -4. What goes here? Fantastic. You will not get full credit for that. That is not simplified. You need to simplify it. This is not simplified. Okay. What do I get? Yeah? What I asked for? The 25th term. Oh, that's not so bad because 4 times 25 is 100. Yes, Amelia.
It's -93.
It's -93?
Yeah.
Do we trust her?
I think so.
That's what I got.
Okay. They trust you. That's good. -93, yeah? All right, now I have a question you're going to love.
Oh no.
Are we gonna go
What is a geometric sequence?
Oh, that's great. I love it, Kevin, but that's not the question yet.
Oh.
What's this look like on a graph?
got it?
A line. It's a line. It's a line. Yeah. There's no such thing with a line and a squiggle.
It's a
Stop.
constant line.
There's no such thing as a non-constant line.
Or like
It's called a
Straight
set.
line?
All lines are straight unless you're me and you don't draw very well. What's the y-intercept?
Actually,
7. What's the slope? -4. You're subtracting 4, subtracting 4, subtracting 4. The slope is -4. I know.
That's what I mean. That's what I mean.
Sure, Dad. Sure.
This is something like all lines that are a constant of some sort. They're increasing or decreasing by a constant
like the
rate.
dotted ones, I think they meant
You mean asymptotes? Alright, so if I'm not arithmetic, I might just be a pattern. If I'm not arithmetic, right? Let's go back to Fibonacci. We seem to like him. Pretty smart person.
I don't know what he is,
Fibonacci, who cares? Alright, so pattern, yes. Stop, 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 stop. Pattern, yes. Is it arithmetic? No. But it's a pattern, yes. Is it geometric? So I keep throwing out this word. What's it mean to be geometric? Yeah, you're multiplying or dividing. So this is neither. You can be a pattern, but not be arithmetic or geometric. It doesn't mean there's no pattern. There's just arithmetic and geometric are specific patterns. So geometric, what do we think about geometric? Some of you said, yeah, you are multiplying. Gotta be careful with that. I forgot some serious words in here.
So there's 2 different formulas?
Yeah, for sure. It's a sequence created using multiplication or division, yeah. But I don't want to divide. What should I do instead?
Multiplication of fraction.
Multiply by a fraction. So we're just going to say multiplication, and we'll take care of the division in a minute. The problem with geometric sequences is they grow very, very quickly. So I'm going to give you a geometric. How about, I don't want to start with 2. It's always by 2. 3 times 4. You're going to need your calculator for this. Times 4. That's 48 times 4. 196. What's 48 times 4? 196? 192. Well, I just gave it away. Definitely are going to need your calculator because you're not going to be doing 2 to the 98th power, and that's a little ridiculous, but you're not going to be doing 2 to some ridiculous power without your calculator. So I want you to figure out what are we multiplying by each time? 4?
Yeah.
So you are creating the sequence by multiplying times 4, times 4, times 4, times 4. Previous example, I said 5 was the common difference. I wrote it up here. Matter of fact, I think I even used pink. We can't use D for common difference because it's not a common difference. We are multiplying by, oh, shoot. What are we multiplying by? 4. Great. I don't like using X for multiplication, but it serves its purpose here. Okay, so in this particular case, instead of being called the common difference, it is called the common multiply. Not factor. No.
multiple.
Dividend.
She just said it's not multiple. It is called the common ratio.
I call that
R is called the common ratio. So instead of being a common difference for arithmetic, it's a common ratio for geometric. And the common ratio is the constant
It's all fun and
there's a lot of fractions. Half of life is fractions. Really? Did you get it? Half of life is fractions.
games. You're so funny.
I know I am.
Wow. Wow, that was so big. So
How about this, the multiplier? But it's technically called the common ratio. I feel like my explanations are, my vocabulary is not so good. It happens. Okay. I'm going to do the whole thing that I did last time with the arithmetic. 3, 12, 48, 192. What's the common ratio? 4. So this is 3 times,
One.
okay. So how many 4s?
0. No, but you can't.
Then you get 0. All right, we got to come back to that one. We have to come back to 3. So this is 3 times 4. How many times? And this is, oh! Okay, I can multiply. Well, I'm speaking in tongues. Hold on. 4 twice? No? 3 times 4 is 12. 3 times, oh,
Oh, wait, no.
this isn't right.
it's
This is not right. I purposely did it wrong, just so you know. Occasionally, I make mistakes on purpose, not always. This doesn't work, right? Because we did 4 and it was like, oh, well, it can't be 0 because 4 times 0 is 0 times 3 is not 3.
4 to the
It's power. So this is 3 times 4, 0.
Okay.
And this is 3 times 4 to the first. Do you agree with that? So the next one's going to be 3 times 4 squared. And is that not 48?
Yeah, pretty much.
Oh, I remember.
Pretty much. Nate, it either is or it isn't. 3 times 4 cubed. 4 cubed, I believe, is 64. Times 3, I believe, is 192. Okay. Find a formula, please. Find 2 formulas. Find a formula for this beautiful sequence in pink, and find a generic formula for geometric sequences. Have a neighbor, compare.
Sports to the power.
This is the problem. You want to sit in front, so now I'm going to be like all the time. That's good because then you learn.
What power to the cross?
Or she gets mad.
What? Wait,
Or you get mad.
that's not true because you yep. She talks about math. There's a big difference. See? What do you got for me? What do you got for me? Our beautiful pink sequence.
3 times 4.
P sub n 3 times 4 to the power of n minus
12 to the n minus 1. No. Good. Hannah's like, nuh-uh.
1. 10 dash.
Done. Move on. There's no more simplification you can do. There's no more simplification you can do. So, how about generically? T sub n.
Equals T1
Sub 1.
times 4 to the power of n minus 1.
T1.
It's not T1, it is T sub 1. You have to learn proper mathematical language. T1, I don't know what that is, but it's not math. Sub 1, sub 2, sub 3. Got your calculator? Because these sequences grow quickly, or they shrink quickly.
Exponential.
Well, there you go. That's why it's exponential. Exponential. Yes? All right, here we go. So I want you to, I want an equation and we'll do T sub 25 again.
That's gonna be big.
Well, we'll see. Or it's going to be small. It's going to be big or it's going to be small. So we're going to talk about how do you properly express answers. That's what's going to be the big thing. I know that you can plug and chug, but it's like, what do you get? What's the output? So how about let's do 6 again. 6 is good. Yeah, we did 6 in the last one.
That's a nice number.
You have to have 3 numbers before you can determine what kind of pattern it is. It is.
Oh, I'm doing
162. I think it's 162. I think.
I don't know what you're. Wait, is it? Yeah, that's what's.
Go for it.
times 3. Oh, it's probably just getting
I need to get one of those sliding boards. Constantly erase everything. I want an equation. Oh, perfect. Still a lot. You mean scientific notation here?
I don't know, whatever it
E doesn't exist. That's scientific notation. E is the natural log. E is in science all over the place. E on your calculator. That's your scientific notation. All right, T sub n equals. T sub n equals
6 times 3 power
18. No. It's not 18 to the n minus 1. Like, I know. Someone's going to do it. You cannot multiply a coefficient and a base, or a constant and a base. No can do. Then you get this number on your calculator, and I think I've talked about it briefly. You do not give E for an answer. What does E represent on the calculator? Yeah, 10 to that power. Okay, so how far do you go? All right, watch. 1 point. Oh, no. T sub 25 equals. Oh my gosh, you're gonna tell me out. 6, 9, 4, 5, 7, 7. 6, 9, 4, 5, 7, 7. 2, 1, 9 times 10 to the 12.
Oh, you have to write the whole thing?
Kaveen doesn't want to write the whole thing. How about
too many zeros.
That is not too many zeros. That is not too many zeros. You have to go 12. So I counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or whatever. I like that. 10, 11.
It's too much.
Says who?
My eyes.
No, it's right.
That was not difficult for me. So, you know, what should you write? This is a little over the top, I would agree. This is a little over the top, I would agree. However, do not complain. How hard is it to write, take your hand and write down the number straight from your calculator? It is not. This, my friends, is the answer.
Oh,
I have to write the whole thing? Yes. Yes, you do. It could be so much worse. I could make you do all the multiplying out, which of course I would never do. But okay, 2 more. Both are unique. What about? How about? I don't like using 2, 3. They're also boring. I keep using. Oh, let's do a fraction. Aha! Let's do a fraction. The halves aren't so bad. The problem is where to start. Let's do. I can't start with an even number because then it divides. Okay, how about this? Bless you. I'm not done. It's got a fraction and it has alternating positive negatives combined. As a fraction with alternating positive negatives combined. Try. Say it again. The equation. Yeah.
oh,
And then we're going to talk about your calculator again. Find the equation first. Then we will discuss the calculator. So the air conditioning is on all day. Heat's on, then the heat turns into air conditioning, and then it's too cold, and now it's stuffing too hot. I haven't asked you to find any term number, so no calculator necessary. Yet. First term. 10. First term is 10. Everything starts from the first term. You start with 10 and then you multiply by a half, multiply by a half, multiply by a half, etc. But it all starts from the very first number in the sequence, which is always the first term. First number in the sequence is always the first term. You don't start with the -1th term. You don't start with the 107th term. You start with the first term. All right, help me out. What's R? -2.
negative.
Parentheses, parentheses, parentheses. You have to use parentheses. They matter. If you don't have parentheses, excuse me, every value is going to be negative. If you don't have parentheses, every value is going to be negative. I'll show you what I mean by that in a minute. Okay, and what's the exponent? Are you sure? Okay, yes. No decimal. No decimal. So I'm going to show you what's it going to look like when I ask you for, what's 2 to the 2? I got to find a term number that's going to demonstrate what I want to do. Okay, let's find the 20th term this time, otherwise it's going to be too small. We should play around with that. I want your answer as a fraction. I want your answer as a fraction. That's what I said. The sequence is given to you as a fraction. You give me your answer as a fraction.
Okay.
Fraction.
I don't think that's how it works.
Your calculator won't do it. Your calculator won't do math frac. It's too small. The calculator will not do math frac. I don't think it will.
Oh, it's like, no, over 10%.
How many of you plugged something into your calculator?
Oh, yeah.
All right, and then you got some decimal answer. How many of you plugged in and you got a decimal answer? Okay, and then you tried math frac, and your calculator said no. So here's what happens. You do the whole problem, and I got negative 1.90734,863 times 10 to the negative fifth. Yes, I hear confirmation from a lot of you. All right, so you get negative 1.90734,863. Okay, and then the calculator math bracket, it doesn't work. Yeah.
I think I have it as a fraction. Sure.
Not your graphing calculator. You want to show it to me? I'm confused. What'd you get?
No, I'm just gonna use cord.
All right. How'd you get that? So Tyler said, I think I have it as a fraction. She showed me an answer and it looks legit to me. What'd you do?
So I've noticed that all the numerator, it was basically 5.
The numerator was basically 5.
So
Agreed.
And then I just had 2 to the power of 19.
She did 2 to the power of 19,
And then 7.
and then she put them together. Watch. Let's just look at negative 1/2 to the 19th. This is negative 1 to the 19th over 2 to the 19th. Agreed? Yeah? What's negative 1 to the 19th? Negative 1. Your calculator does 2 to the 19th. 524,288. I agree. Don't forget your commas. Commas matter. Commas matter.
I don't know how to
Wait, what?
Every 3.
Oh, everything? Okay.
Start with the start on the, what is that, the right? Every 3 to the left. Okay, but there was a 10 in front of it. There was a 10 in front of it. So this becomes negative 10. 524,288. No. Reduce, reduce, reduce. Reduce. So this becomes negative 5 over 262,144.
Can we just take the negative 1.9, whatever times
Can you take this?
And put it over.
No. You can't have scientific notation mixed in with a fraction.
Well, what if
No. No.
Okay.
No.
Let's see what we get.
No. All right, very last one. Very last one. Let's see, I already used that. I want you to find a formula and let's see, find T sub n and T sub 15. T sub n, that means the generic formula. T sub n means the generic formula. Okay, here we go. I'm purposely not reducing to make it a little bit easier for you. These should be reduced. It's a little difficult to find the pattern if you don't. If I do reduce it, it becomes a little messy. What are you adding each time?
You had one.
Yeah, one to the numerator.
You're adding 1 to the numerator?
And then you're multiplying the denominator.
But you're multiplying it to. So are you arithmetic or geometric?
Both. Because you're so cool, you're just both.
Okay, so technically it's not both.
It's geometry.
Neither.
All right, it's neither. However, you can't be arithmetic and geometric as one specific sequence. However, this is a combination. There's a sequence for the numerator. So the numerator, what are you adding each time? Arithmetic. The denominator, what are you multiplying by each time? Geometric. So you write a separate formula for the numerator and a separate formula from the denominator. You do that already? 2 separate formulas. So you have to look at them separately. Sub n. Sub n. TN, I'm sorry, Victoria, is Tennessee. TN is Tennessee.
No, she won.
Sub n is a sequence. TN is a element on the periodic table, is it not? No?
Is it named after Tennessee?
Tennessee, yeah. Numerator, what do you get? What's the numerator?
Yeah.
N plus 1, that's it? The numerator is n plus 1?
It's still divide.
Sweet! What's the denominator?
5 times 2 to the power of n minus 1.
Cool. I asked you for the. Oh. Yeah.
So what is first? Actually, no, I got it. Never mind. I asked it wrong.
Fantastic. Well, I could help. All right. The 15th term. Okay, well, the numerator's not so bad. That's 16. That I can handle. The denominator, 2 to the 3rd, 14th. 2 to the 14th. 10 is 1,024, 2,056, 5,000, 10,000 something. What's 2 to the 14th? 2,000 something, no?
16,380.
16,000, what is it?
384.
With a comma.
Yeah, what's wrong?
Times 5 is even bigger.
81,920.
And 20?
Yeah.
Nope. Nope. Reduce, reduce, reduce. Reduce. I didn't reduce when I gave you the sequence because I thought it would be a little bit too difficult to start off with. You have to reduce. Divide by 4. Divide by 16. Sweet. What is it?
1,920.
Is that right? Bam! Geometric, arithmetic. There they are. Okay, so we'll take a break. 44. Go to the bathroom now. Not go to the bathroom until we'll get back.
There's no T and L.
There's a TM. TM.
There's a TM, but no
T A
N.
T B T C T E T M T L T I. But no T.
Okay. Where? Oh, it's here? I have a trig meeting until 3:30. We'll try to come after that.
What's your side getting?
Oh,
No, why not? What are yoga fees?
Yoga is
Okay,
so
let's
fun.
try like to not stand right in front of the door.
Yeah, just like
we're just making sure no one can come back.
Yeah.